This is 404 loading, where I document what I am learning in cybersecurity and networking through practical labs. In this video, we will configure OSPF Loopback interface and verify OSPF interface behavior in Cisco Packet Tracer. So let's first set up the topology. Here we will use two PT router and one switch. That switch will be 296024 TT connected through copper truth table. First, creating a simple topology with two routers connected through a switch. Both routers will participate in the same OSPF network. Now let's configure router 0. Router 0 CLI in enable config int f0/0 no shut IP at 10.0.0.10 255.0.0.0. So we configured the first Ethernet interface on router 0. The no shutdown command enables the interface because router interfaces are administratively down by default. Exit. Now router OSPF 1 net n dot 0.0.0 dot 255.255 area 0. Now enabling the OSPF and advertising the connected network. OSPF uses network statements to determine which interfaces participate in root exchange. Area 0 is the backbone area required for OSPF communication. Control Z, copy, run, start, reload. Saving the configuration and reloading the router. This helps verify whether the configuration remains persistent after reboot. Reload done. Let's configure router 1. CLI in enable config int f0/0 no shut IP at 10.0.0.9.255.0.0.0. So now configuring router 1 within the same network. So exit router OSPF 2 net 10.0.0.0 0.255.255.255 area 0. enabling OSPF on router 1. Even though the process ID is different, both routers can still form OSPF neighbors. Ctrl Z, copy, run, start, reload, saving and reloading router 1. Next, we have to verify OSPF interfaces. So let's again en show IP OSPF init. Now checking OSPF interface information on router 1. The command displays OSPF timers, interface states, and network participation detail. Let's go to router 0. We'll do the same thing. En enable show IP OSPF in. Verifying OSPF interface behavior on router 0. Now let's check loopback interface. Const int lo0 IP at 20.0.0.10.255.0.0.0. Now creating a loopback interface on router 0. Loopback interfaces are virtual interfaces commonly used for router identification and routing protocol testing. Unlike physical interfaces, loopbacks stay up unless manually shut down. So exit router OSPF 1 network 20.0.0.0.255.255.255 area 0. Advertising the loopback network into OSPF. Once advertised, other routers can learn this network dynamically. Ctrl Z, copy, run, start. Saving the configuration. Now let's go for router 1. Const int lo0 IP at 20.0.0.9.255.0.0.0. Now creating a loopback interface on router 1. Exit router OSPF 2 network 20.0.0.0.255.255. Oh, sorry. We have to do the reverse one. 0.255.255.255 area 0. Advertising router 1 loopback network into OSPF. Now Ctrl Z, copy, run, start. Saving the configuration. Now we have to verify after reload. So let's reload both router. Router 1 is reloading. Reloading both routers to verify that saved OSPF configuration persists after reboot. That's the router 010. Reload. In router 0, let's do the enable show IP OSPF init. Checking the OSPF interface details after reload. Let's go to router 1 and do the same thing. En show IP OSPF init. Verifying OSPF status and interface participation on router 0. So everything is perfectly done. That's why both of them is still green and working properly after reloading this much time. So that's it for this lab. This covered OSPF interface verification and loopback network advertisement using dynamic routing. More labs as I continue learning. Keep learning. Take care. Bye.